everybody. I'm Dale Roth with Stumpy Greenhouse Manufacturing. We are both the designer, the manufacturer, and the installer of the structure in which we stand. This structure is made up of really what I would call 4 rooms and a corridor. This room, which we call the head house, and then 3 production rooms going out this way, and then a central corridor. Here in the this structure, we are, I guess you're using as your lab kind of research and that type of stuff. We did not supply the internal parts of this other than we have a sensor in here, don't we?
Not in this room.
Not in this room. Okay, so no sensors. This is Art O'Hare. He's with Link 4. Link 4 is an environmental controls company and is our subcontractor on this. Art will carry on the conversation after we move to the other rooms. I explain a few pieces of the products and the equipment in there. So with that, we'll cut it off and move to the next room. Thank you for joining me in this room. What I will point out is the equipment, and the equipment in each room is consistent from room to room to room. In other words, each room has its own self-contained equipment, but it's identical to the room adjacent to it. For maintaining the environment, maintaining the temperature ranges within this room, we have a number of pieces of equipment, and I will point them out. On my left is a pad wall system. They also call it a wet wall system, and that is through, in conjunction with the fans that are on my right, exhaust fans. We get negative air pressure, so they're blowing out. Air is brought in through the pad wall system, and through evaporation cools the room. You have to, if you have negative pressure because the fans are pushing air out or pulling air out of the room, you also have to have positive pressure to equal out. So in this case, the central hallway, and I'll just point up here, acts as a plenum. There's a ridge vent up at the top of this, so when the ridge vent opens, the exhaust fans come on, and the air is drawn from the corridor through the pad wall and out the other side. So in other words, we're cooling the house through evaporative cooling system. We're heating each of the rooms through a gas-fired unit heater, and it's up over here in the corner. How we're circulating the air within the rooms then is through HAFs, or horizontal airflows, and you can see them up in the peak here. They move the air so that we don't get inversion layers, warm areas, cold areas throughout the building. Additionally, each room has shade systems, and those shade systems are used for sun protection or to help you cool. They're also used at night for an energy blanket, so you draw it close at night so you're not losing as much heat out through the roof. So if I had to go through the equipment in each room, there are exhaust fans, there's a pad wall system, there's HAF systems, there's a unit heater, and central to all the rooms is the plenum with the ridge vent. So the ridge vent always has to open if there's an exhaust fan going. Is that kind of clear? Did that make sense to everybody? The glass is it's a glass-walled system, 1/4-inch tempered glass. It's pretty normal. It's a galvanized steel frame with aluminum bar and cap. I think that's all I probably have to say about equipment. You can see what happens that greenhouses heat up very quickly, and as such, the snow slides off. That was that noise. I'll introduce Art O'Hare, who will run you through a few of the maintenance things on the equipment, and then we'll also move over to the environmental controls part.
Hi, my name's Art O'Hare with Link 4 Corporation. This is our iGrow control system for your greenhouse. we have 3 identical systems in the 3 climate zones and another system in the hallway, the corridor. There's really very little maintenance to concern yourself with the iGrow. This is the control panel for the various equipments that Dale explained, which are our fans, pad system, shade, and heating system. Inside the cabinet are the relay contactors that control the high voltage equipment. There's a circuit breaker to power down the controller and the panel. Each piece of equipment has branch circuit protection in the corridor. A reset button on the transformer, and a reset button, a red reset button on the controller. In addition, should the controller fail, for example, if the front panel glass were smashed or something had damaged it, there are mechanical override switches for each piece of equipment, so you could still maintain conditions in the greenhouse to safeguard what was inside, even if the controller failed. So all of the equipment in this room is controlled by this panel. In addition, we have a motor controller for your shade system up above. The shade system is controlled automatically, of course, but can be manually overridden from the iGrow 800, as can all of the other equipment in the room. In addition, the shade system has a manual override on its box as well. Should the shade system fail to operate, one of the things you would want to check would be this green LED here to make sure you had power. And there's also a red button located here for a thermal overload. If the shade motor were to overheat, the thermal overload is a safety device that will shut down the power to the shade motor to prevent damage. And the last thing in here is a 2 amp slow blow fuse that goes right here that also powers this motor controller. The shade motor, as does the vent motor in the corridor, all the shade motors I should say, have what are called mechanical limit switches. So that means that if we were to just decide to manually open this shade, and we can hear the motor and we can see the shade beginning to move. The shade takes about 1 minute and 40 seconds to fully deploy in either direction. If we were to leave this switch in the open or the closed position, and simply walk away, the mechanical limits in the motor will signal the control system that it has reached its maximum travel time, either open or closed, and shut it down automatically. So since it's getting a little warm in here, we've opened it about halfway, I'm going to stop it and put it back to the closed position. And then you can see it's moving right up there as it continues to deploy. There's one other maintenance issue to be aware of that involves the pad and pump system. The sump pump in here is plugged into a GFI outlet. So should you see, for example, an indication of a temperature rise in the compartment, and yet the controller shows that the pad pump is on and functioning, be sure to check that not only the circuit breakers, as you would do anyway, but also that GFI outlet there to ascertain if the pad pump is indeed functioning. And if any of the compartments reach a critical alarm, the computer system will send out text messages to alert personnel of that danger. Here we have the sensor array, and there's a similar sensor array in each compartment. Inside the radiation shield is a digital temperature and humidity sensor. This is typically deployed just above plant level. The HAF fans circulate the air, which will ensure that you get uniform readings from the sensor. In addition, there is a backup sensor located on the top. Should the primary sensor fail, the control system will automatically switch to the backup sensor. Okay, now I'm going to present a little hands-on training presentation for you so that you can see up close how to manipulate the control panel in each of your greenhouse compartments. So here we have the iGrow system, and we're going to do an overview of the 100 series. You have iGrow 800s in the 3 rooms and an iGrow 400 in the corridor. The 800 means you have 8 channels and the 400 means you have 4 channels. Other than that, they are identical controllers. They are all networked together as well. There's a touch interface on the front panel. There's also a USB interface so that you can do many things such as save various configurations of how you want the climate to be controlled without having to reprogram for a new scenario each time. So you could have literally hundreds of different scenarios of how your temperature and humidity set points are arranged and load them in seasonally or when you've changed whatever plant material is in that compartment. So as we mentioned, we've got the iGrow 400 and 800 with the 4 or 8 outputs. With the vent curtain control, controls heaters and fans, and the weather station up top. Okay, now we'll talk about software overrides. So if you depress the home button, and then you were to depress the channel 1 button, you can then force that channel to either auto, on, or off. Then you press OK, and then now switches to on. In addition, a green LED will illuminate. You simply repeat the process to change it back to auto. These are the hardware overrides that I mentioned earlier. These are accessed by opening the door to the panel, and then you have 8 slide switches for each channel, which mimic the function of the soft keys on the front panel. And you have that red reset button in the middle. The system settings are retained in non-volatile memory. In addition, you will have been able to save backups of your configuration on USB and also on the hard drive on this computer. Now this is a scenario of a typical small greenhouse setup where you have a heater, HAF fans, pad louver and pump, and in this case exhaust fans. Very similar to what you have here basically. Except you're using the roof vent plenum instead of the pad louver. Exhaust fans, heater unit. So basically the way the system works is like your thermostat at home. You would have a set point, which is a temperature range that you wish to maintain. So that range is a heat set point and a cool set point. So for example, if you have between 60 and 65 degree set point, then if you're within that range, you're in what we would consider the normal stage of the system. The system also has cooling stages, which number 6, and heating stages, which number 2. The system stages are also set in a width of degrees. And in your case, I've started you off with a 3-degree stage width. So, as an example, with a 65-degree cool set point and 6 cool stages, cool 1 being the least aggressive cooling and cool 6 being the most aggressive cooling, if we were to be above 65 to, say, 62, that's within 3 degrees, so we would be in cool stage 1. If we got to 64, that's more than 3 degrees, so we'd be in cool stage 2, and so forth. So as the temperature rises, the system will switch to a higher cool stage, and then more equipment will activate in order to deal with the higher temperature. The goal being, of course, to drive the temperature back down to the normal stage, which is within our set point. The same process works in reverse for heating, although there are only 2 heat stages. And in your facility here, you only have one unit heater. So in a sense, you really just have one stage of heating. So if we are below, say, whatever the heat set point is, 60 degrees, for example, then the minute we get below that, we just turn off all the cooling equipment and turn on the heater and try to drive it back up to 60 degrees. Another factor in controlling the temperature of the zones is what we call a dead band. So again, bear in mind that in our example, we have a 65-degree cool set point and a 3-degree stage width. So if we were at 64 degrees, we were in cool 2, we would have the fans probably on high speed, we'd have the pad pump running, we'd have the vents open, we'd have the HAF fans probably off because they're just competing with the exhaust fans. So as the temperature drove down towards our 65, the equipment would cycle accordingly. Where the dead band comes in is when it got to the 65, say 64.9, that's technically within our dead band, which is our normal zone. But rather than just shut the equipment down, which would cause it to oscillate or cycle, we would drive the temperature an additional 2.5 degrees of dead band in your case. So I have already programmed all these things for you. This ensures that you don't continually cycle between heating and cooling and so forth. And we've named all of your channels for you. The set points, you actually have 3 at your disposal. They all work the same way, and you get to pick how many that you need to use. There's the day and the night, and then what we call a differential, or diff. So an example of that would be, say 6 a.m. to 6 p.m. we're in day, 6 p.m. to 4 a.m. we're in night, and 4 a.m. to 6 a.m. we're in diff. And I'm a controls person, not a grower, but I think growers will tell you that there's advantages to having the ability to radically change the set point, the temperature environment for that brief hour or so just prior to dawn. So to access the equipment, which I have already done for you, press the menu or the OK key and you get to your main menu. And it always tells you which menu you're in right here. In the System Setup menu, you have Equipment Setup. Once you go to the Equipment Setup, you have your 8 channels, or in the case of the iGrow 400, your 4 channels. And you can also use the front panel keys as shortcut keys instead of using the wheel. So instead of using this wheel here, you can use these as shortcuts. So this would equate to 1, this would equate to 2, and so forth. So if we select our exhaust fans there on channel 3, or rather the HAF on channel 2, and channel 1 has no name. So we go to the settings for channel 1, we go to the initial settings, set name, backspace out the default name of channel 1, and put in whatever name we want for the equipment that's connected to that channel. Then we save our settings. So what did we just do? We changed the name from channel 1 default to heater 1, which is a custom name. Then there's the staging of the equipment. We've talked about the cool and the heat stages. For this example, we have a heater on channel 1. We go to assign the stage that it turns on in, and we can do temperature or humidity stages. We choose temperature, heater 1 stages, and then we simply check the box where we want that heater to activate. Since it's a heating device, we would not check the box for any of the cool stages here. The bottom row is left, right, and up, down arrows to navigate your cursor. So now based on the set point, whenever it's in heat stages 1 and 2, that heater will activate. The set points is probably the thing you would be manipulating most often as a user of the system. So you select set points, temperature set point, set day. On the left we have our heat set point, on the right is our cool set point, and they're labeled down below. And you can actually see in this case the stage width is 1 degree, and it gives you a little bar graph of the width. Larger one being our normal stage, the 6 cool stages to the right, the 2 heat stages to the left. So we can change our heat set point to 72 there. Go over to the cool and change that to 75. Leave the value of 1 degree on our stage width. And then set the time that the day set point will begin and the night set point will begin. So it changed from 8 a.m. to 6 a.m. So our day set point is 6 a.m. to 5, and we've set the desired temperature to be between 72 and 75. Now at this point, the presentation will have us calibrate the sensor. I'm going to run through this part fairly quickly, then we're actually going to go out into the greenhouse and put the system in automatic and program some stages and watch it happen in real time with the actual equipment in that compartment. So should you need to calibrate a sensor, you do it here. This is a useful way to test things. This is on the front panel main display. It always shows you what stage that system is currently in. So it would either be normal, cools 1 through 6, or heats 1 through 2. So in the scenario in the presentation, the temperature in the greenhouse went up to 76, but since the set point was under 75, the cool stage kicked in to stage 1. If the temperature had continued to increase, then it would go up to cools 2 through 6 as needed. You can also track energy consumption of your equipment. You program in how much current a fan, for example, or a heater would draw. And then you can log that energy used and cost based on information from your utility. These reports can be copied to the USB device that we discussed earlier and exported into an Excel format for later analysis. Each channel also has a timed override, and that allows you to activate that channel like a time clock for special circumstances, such as if you were spraying for insecticide, perhaps you might want to assure that the fans were off tomorrow for a 2-hour period. You would use the timed override feature to achieve that. For example, here they're saying if you had visitors every day at noon for an hour tour, you want the pad pump off between 12 and 1. So we'd go to the pad pump channel, override, enable it, start at 12, duration is 1 hour, and we do it daily because it's every day at noon. Until such time as we decide to discontinue it, then we would go in and disable that feature. This is how we save a configuration of the control system. So you would have you can save the configuration to two places. You can save it on board the controller in a non-volatile memory area. You can also insert a USB stick in the controller, save it to that USB stick, then remove the stick for safekeeping. In addition, with the iGrow software that we'll be covering later, that enables you to see and control all three of, in your case, all four of the iGrow controllers simultaneously from a personal computer. And this is our toll-free number for 24/7 support if you should ever need to contact Link4 support team. You can email or call us with this contact information.
There I didn't understand how I program room by room. I understood how you can do the programming in general, but room by room?
Yes, since each room has a controller like
Yes,
this.
but from the computer,
Yes,
you can do it?
Yes, and from the computer you can see all of the rooms simultaneously.
Oh.
So then you double click on the controller for the room that you want to make your changes in. Should it be necessary to ever change out any of the equipment on your control system, let me just point out the basic methods you would use. On the motor controller, you can change out the individual components, or Link4 can provide you with the back panel assembly. That way you do not have to disturb the conduit or the enclosure, and you would just be landing the wires on the circuit board, assuming it was the back panel enclosure that were damaged and being replaced. Alternately, if it were just the circuit board that were needing replacement, it's easy to replace just the circuit board, leaving the rest of the components within the enclosure. On the main panel, all of the relays and contactors are DIN mount, so they are easily replaced. You will have some spare power packs here. These power the actual iGrow controller. If the controller itself should ever need to be replaced, it is held in with 4 screws here, and all of these terminal blocks, and I'll use an unused one here, actually can be removed. So all you need is to unscrew the 4 screws, remove the terminal block, insert the new controller, replace the terminal block and the screws. As with replacing any kind of electric component, you would of course power down the system. You can power down the controller by unplugging this power pack, or you can power it down by turning off this breaker here. So we're going to program a couple of little scenarios here. And where we have to begin with is, I have named the equipment. So we have our shaded open and close on 1 and 2. Open is on channel 1, close is on channel 2. Exhaust fans low on channel 3. Exhaust fan high on channel 4. Horizontal airflow fans on channel 6. The pad pump on channel on 5. The pad pump on channel 6. Let's go over that again. Take 2. So here we have our shade open and close on channels 1 and 2. Exhaust fan low on channel 3. Exhaust fan high on channel 4. Horizontal airflow or HAF fans on channel 5. Pad pump for the cool cell on channel 6. The heat on channel 7. And channel 8 is available. So to start off, we're going to set a set point, because our set point right now is currently 68 to 72. It is 76.2 in this greenhouse at the moment, so we are in cool stage 4. So we access the main menu, set point, the temp set point. We're going to just set the day for now. So we'll run the heat way down. Make it 60. And we'll set the cool set point. Let's back out and see what our current temp is, because we want to do this in stages. And it is currently 76.5. Notice when we back out and we go back in, it remembers where we went. So all we have to do is keep hitting the OK button to get back to where we started. It moves slowly here in tenths of a degree. If we want to make a large scale change, we can hit OK to expand the window, then it'll go a lot faster. So we'll say 75, give or take a few tenths. That, and save. So now we have 76.7 is the current temperature, and the day set point is 75.3, so we are in cool 5. But notice that there's no equipment on, because we haven't actually told the equipment what to do in the particular stages. So we go back to our menu. Number 4 is stages. We'll do temp stages. And we have a grid showing the equipment on the left, the names of the equipment, and then we have the different stages across the top. As previously discussed, we have 2 heat stages, normal, which means we're within set point, and 6 cool stages. Notice that the shade has the NA, because the shade is not staged by temperature. The shade is staged by light level outside and by time of day. So we use these bottom arrows now convert, or bottom buttons convert to arrows, so we can move our cursor. So, we don't want the exhaust fans on in the heat stages. And we are currently programming the low speed exhaust fan. So what we'll do is just go to the cool 2 stage for the low speed fan and click the box.
But why does it go to the cool 2 and not to the cool 3 or 4? Why do I decide that?
Well, we want to use the cool stages so that we use the least amount of equipment to achieve the goal. Think of it like when you're at home, you might turn on you wouldn't turn the heater on to 80 degrees just because you were a little chilly. You do it in stages. So right now, this exhaust fan will be on in cool, it'll be off in cool 1, on in cool 2, on in cool 3. So we're just going to use this low speed fan in 2 places. Go down to the high speed fan. We're going to kick him on in cools 4, 5, and 6, because that's the high speed fan. The HAF fans, which are really just for air circulation, and we're actually using those for heating as well. So we'll go ahead and turn those on in both heat stages. Even when we're within set point, we want to have some air movement in here, so we'll have them on in the normal stage. And we'll make those our cool 1 stage. The pad pump, the cool cell pad, that's our most aggressive cooling device at our disposal. So we'll turn him on all the way up here to cool 6. Finally, the heater, Since we only have one heater but 2 heat stages, we'll turn him on in both heat stages. So now all of the staging for all the equipment in this room is programmed. So we hit the home key, it asks us to save what we did. We save it, and now things are going to start to happen. We're in cool 3, so the exhaust fan load kicked on. Assuming that the breaker for it hasn't been left on.
Dale Ron again at Stubby, just giving an overview of how a pad wall system takes. There's a water supply in the holding tank for water. There's a float valve that just keeps the water at a proper supply. When the pad wall is in the on situation, water is through a pump that's in the bottom of it, is pumped up through the piping here and across, and then it percolates down the wall, returns into this capture tube, and goes back into here. As part of the overall maintenance, there is a filter at the very top that when it gets debris in it, you simply have to turn the valve. It's a bleed valve, and it'll clean the filter out. It's a fairly simple, self-contained system that requires very little maintenance.
On manually to fill the tank. So we hit the soft key. If the pad pump is currently in auto, we're going to say force it on, okay, and there it goes.
You can see the water is coming, percolating. So if I want to clean that out, all I just do is turn this.
How often do you anticipate that will be cleaned out?
Every couple of months. You'll see it, that's why it's clear. You'll see debris in there. And then it's rather simple just to turn it on. You can see a little debris is collecting.
Yeah.
So I can turn this on and it'll start to filter out. But it's best to let it run. I mean, it's the first time it's in operation. So you're going to get probably more debris.
And that one, when do you use that one?
This?
Yes.
It's just an overflow hose bib.
No, the red one.
Oh, the red one. Oh, if you want to turn the water off to the whole system, in other words, you're repairing something, this is just your gate valve for turning the water off to the whole system. Or if you need to reduce the flow, there's too much water going up it, you can restrict the flow. Sort of like a faucet on a handle, or a handle on a faucet, you can just restrict the flow.
How long should these pads be effective?
The pads are really, the longevity, I think is really what you're saying, is based on a couple of issues. One is your water quality or lack of water quality. If you have a high lime content or a high alkali content, they can get coated with white mineral deposits. What you'll need to do then is just let them, when they're dry, just take a brush, like a broom, and knock some of that off. And then the other part would be if it's a self-contained system, so you shouldn't get it unless you get algae. Algae will inhibit some of the evaporation of it. But you can already feel how cool this is coming out of here. It's very effective, especially in a climate like Utah where you have dry air. If you're in a humid area, it's not as effective, but in dry air, it's very effective in cooling.
Is that good correctly since
Yeah, this is actually
more
got
water?
it's actually has to tip that. That's all you do. And if you ever do need maintenance, you just simply pull these out. There's only pressure points that's keeping them in. and then your pad can come out. They've been made, growers use them all over the world just to be very effective. If somebody damaged one, they're in sections. You can kind of see about this wide. If somebody, like sometimes you're in here, somebody jams something all the way through it. You know what I mean? It just happens. And you need to replace. You just replace one pad, one little section.
And can we get them at Home Depot or where?
Any probably horticulture supply. We have to supply some for as our closeout. We have some remaining, but yeah, you can order them. They're not real expensive. It's cardboard, basically, a treated cellulose material. On the exhaust fan here, they're sealed bearings. There is a maintenance issue long-term with any belt, just like you would have on a car. If the belt does loosen, there are adjustments that can be done, and it's in the user's manual. And it'll show you a two-step process of loosening the screw and tightening it, and then making the adjustment.
We're going to pull up a report on what the temperature has been in this compartment for the last hour. We go to the main menu, we go to reports, go to graphics, temperature, inside temperature, the last hour. And we see that it was up around 78 degrees in here, and then when we programmed in the cooling stages and changed the set point, the temperature has dropped dramatically and is now around 68 degrees. We can go home and see what it, okay, now it's actually at 65. And the humidity's gone up considerably too, and it's continuing to climb. Okay, now we're going to discuss how to control all three of the growing compartments as well as the corridor. These are known as zones on what we have here, which is the iGrow software. So we have zones 1, 2, 3, 4. If you double click the zone, you gain access to it where you can see all the channels that we saw when we were in the greenhouse earlier. The exhaust fans, HAF, the pad pump, the heater. The little tool button here lets us go in and look at the different, all 8 channels, and actually manipulate them. So you double click on the channel, it shows that it's in auto. And then the staging that we did from the control panel of the iGrow, we can do all of that right here from the computer. So what I'll do is cancel this out, go back to my view here. And there are different views at your disposal. There's the start page, where it tells you how many iGrows you have on the network, how many hours of data have been loaded, highest temperature and lowest temperature ever recorded. Here's our weather station data. The outside temp is currently 27.9, wind at 21 miles per hour, direction from the north. Light is at 792 watts per meter squared, and there's no rain.
The weather station can also be saved if you want to keep track of that for
That is, yes. The question was, can the weather station data be saved? And yes, it can. All of the data of all the sensors in all the compartments can be saved and tracked virtually forever. We go to a list view. Earlier, I created a demonstration controller. This can be utilized for just experimentation purposes where you don't want to manipulate any actual equipment in the greenhouse. So we'll go ahead and leave that demo controller there. The zones 1 through 4 here are the actual compartments. So it gives us the current status of each of those. Zone 2, if we'll notice, has a very low temperature when compared to the others, because earlier we went in there and programmed Zone 2 to cool the compartment down. And I've actually set the set points in Zone 2 to an unrealistic 52.3 to 59.3. But it's doing its best. It's at cool 6, which is the maximum cool stage, and the current temp in the compartment is 66.5. So we go to the toolbar for number 2. Let's go to that day set point. And let's change it back to something a little more energy efficient. $70.0, update it. The computer, by the way, gets a snapshot of all the zones about every 15 seconds. So the information we're seeing is 15 seconds old. Down here it says it's writing and reading the configuration because we just made a change. And now our change has taken effect. So, excuse me, zone 2 is now set for 70 degrees. Oh, I think I actually set the heat there. So. Now, yeah, now we've gone down to cool 1, down from cool 6. Again. So I actually set the heat to 70. And then we'll make the heat 50. Cool 70. The status of the computer, of what it's doing with the network, is down on the bottom of the left screen here. So it'll occasionally say that it's broadcasting weather data, or that it's writing something to one of the controllers if we've made a change, or if we're not making any changes, then it's just going out and doing snapshots. Every 15 seconds it looks out at all of the compartments, grabs the data, and brings it to you on the screen. So now what we would expect to see, since the current temperature in Zone 2 is 66.9, which is above 50, but below 70, we are in normal stage. So in normal, the only equipment that we would probably have on would be the horizontal airflow fans. Now we can go into Zone 2's pad pump. Force it to off. It turns yellow when it's going out and getting data, and then when it does a snapshot, it goes back to clear. Change my view to a detailed view. And here I can see the status of the equipment. The green light shows that the HAF fan is on. But notice that the pad pump is now off, and it says it's in override in parentheses because we just told it to turn off irregardless of what the set point temperature was telling it to do.
So let's see that you change the parameters. Is it going to be to go automatically to auto, or you have to again put it in auto? Let's see you change the parameters that need the pad on.
In this case, the override that we did is just a force it to off until I were to put it back to auto.
Okay.
The other kind of overrides you can do, however, would be a force it to off only for 1.5 hours every day. Then it goes from auto to the forced override back to auto again by itself. Or maybe you just wanted to do it tomorrow. You can set it to do it the one time as opposed to daily. And then it'll just occur the one time. So we'll go ahead and put it back to auto. Update. And we'll go ahead and stay in this screen. Reading real-time data at address 2. And we'll see if it turns on again. But it shouldn't, because the temperature range in that zone is within set point. So our stage is normal. So it's 69.8. So now what we'll do is let's see if our heater is in auto. And we did program the heater to come on in heats 1 and 2. So let's this time force, we'll go ahead and raise the set point. You can use the arrows, or you can just go in and type in what you want. So we'll make it very hot in there. We'll go from 90 degrees. And we'll say that we want it to heat up to 80 degrees. So the cool set point is 90, the heat set point is 80, but we know the current temp is around 69. So as soon as we transmit this data by updating it, we're going to see it go from temp stage cool 1 to temp stage heat 2. And we're going to see that the HAF fan will remain on and the heater will activate. So we're waiting for our next update, which should be in a few seconds. Okay, so we are in the heat stage, and the heater did turn on, as shown by the green light. The green lights on the computer are actual feedback from the green lights on the controller. So for example, if this were the controller in question, this green light that you would see illuminated inside the greenhouse matches the green light you see for that same channel on the computer screen. Now we'll go ahead and change the set point back to something. Turn that heater off. So we'll say 65 to 70. Now bear in mind we've been doing our experimentation here with zone number 2. Back all the way out, there's zone 2, zones 1, 3, and 4. Let's go ahead and go back to zone 2 and save what we've done. So we go to the toolbar, tool button, save to file. Name the file anything you like. You can save it to any default position you like, but the current one is in the Link 4 iControl PC, iControl 100 folder. And we save. So now the set point, all the staging, everything we programmed into the Zone 2 controller is saved under that name. So however many times you change it to do any type of experiments or research, you can save, you know, your own little scenarios and then put them on your USB sticks. The same holds true with the data. So it gathers historical data on all of the sensor information as well as all the equipment positions and so forth. I would suggest that you get US and just standard USB sticks are fine, and have them permanently installed in the controllers, and then you can program them to log the files to those sticks on an ongoing basis.
If you can control the programming from the box within the house and from here we could set passwords. What I'm thinking of is security. Who was it that changed what when? So we have a record of what was changed and how it was changed. Is there any way to record who changed it by an ID number or something like that?
No, but you can set a password. So you can set a screen password so that they cannot access the control panel here. And then use the Windows password for the computer where you can access all of them. So if someone forgot the password of the controller, you could go in through the computer and change it. Now, it might not tell you the who, but it will tell you the what. So if you found out that somebody made the set point 80 to 90 degrees, you could go into the graphs and look at that and find out at what time did that occur. And all of these things we will be able to assist you with as well, because we'll be able to remotely access this once they bring the internet into this room, and be able to hold ongoing seminars. And you can call our help desk anytime for help in your control strategy or anything at all that has to do with the control system.
Are there any alarms that come over the computer that would say if it's too cold or too hot, if somebody set something accidentally wrong so the plants don't die or something?
Yes, it has the ability to send text and email messages under certain conditions.
How do we set that up?
Put ogres,
Yeah.
You look closest, right? No, you don't. We need to look at that. That's how we choose who runs this.
Automatic notification. So once you have internet access here, I can work with your IT people, but you'll be setting up the usual one-time things like you do for Outlook, for example. And once you have all that set up, you start listing the outbound email addresses or texts. And all the cell phone carriers, like for example Verizon, you can send a text message to phone number at vtext.com, and it comes as a text, not an email. So you can do a combination of text and emails. Any questions? Well, thank you very much. So the iControl computer is showing us the 4 zones we have in this greenhouse facility. Zone 1 is the far end. Zone 2 is the next one up. Zone 3 is right next door to us here. And Zone 4 is the corridor that runs parallel to the other 3 zones. We are residing in the head house, which is not one of the greenhouse climate zones.
Warranty?
The iControl system, and the iGrow and iControl environmental control system has a 1-year warranty for parts. We have a 24/7 help desk, which we can provide telephone assistance as well as ongoing training in the terms of webinars and seminars. Thank you. This is the back of the iGrow controller here. So we've opened the door because we're going to install a USB stick that we can use for data logging and saving the configuration settings for this zone. I would recommend we leave one installed all the time just to gather statistical data. You can have other ones available that have other information such as the different set points and so forth that you have depending on what kind of climate control you may be doing for a given situation or classroom environment.
Will it let us know, or can it notify us if the USB gets full for storage?
I don't believe so, but that would, I think even a 1 gig, which is like the smallest one you can get, would probably hold several years
Oh, okay.
worth of data.